Turbine blade is a component of a turbine often found in gas and steam turbines used for power generation and aircraft propulsion. It's essentially an airfoil that extracts energy from a fluid flow like steam or hot gas by converting its kinetic and thermal energy into rotational motion. These blades are crucial for the overall performance and efficiency of the turbine. Here In this video, we will be presenting the fabrication process of a turbine blade, which is a critical component that widely used in aerospace, power generation, and mechanical engineering applications that I've told earlier in the video. And these turbine blades operate under extreme temperatures as we have learned, which have mechanical stresses and high-speed conditions, which mean their manufacturing demands high precision and also robust material, which is a strong material that we use in our lab, in our bengkel, and also need advanced forming techniques that we have learned through MEM360 last semester.
So now I'm going to talk about safety during making this turbine blade project. It is because the material shield your skin from sharp edges, hot metal, sparks, and fine debris. Next is glove protection from cuts and abrasion. Glove protect your hand from sharp tools, metal edges, or rough material during handling and fabrication. Second, heat and burn protection, like in welding, grinding, milling. Gloves shield your hand from hot parts, spark, or heat. Apron is crucial to protect your body and clothes. The apron acts as barrier between your body and hot, chips, spark, sharp objects, oils, or chemicals. Keep your clothes clean and free from damage. And second is reduce injury risk, made from thick material. Apron protect your chest, stomach, and thigh from hot metal, flying debris, welding, spark, sharp edges. And third, it reacts as fire resistant in hot work for welding or grinding. Specialized aprons protect against heat and flame more effectively than jacket or normal clothing. This is very important for welders, which is it works as eye protection from welding arc. The welding arc emits intense UV light that can burn eyes, causing arc eye or weld the flash. The helmet automatically darkens to protect your eyes when the arc starts. Second, to prevent long-term damage. Long exposure to welding light can lead to permanent vision damage and skin burns like sunburn. At the same time, it also improves focus and comfort. Helmet with auto darkening filter allow you to see clearly without lifting the hood, make welding easier, more precise, and safer. Make sure slowly moving the workpiece to prevent and mill, broken, and harm user. That's why the use of goggles are important to prevent chips get into your eyes. Make sure to clamp the workpiece properly to prevent the workpiece getting off and give a serious injuries to the user. Even there is a guard, but it is highly recommended to use a glove to prevent hot chips burning your skin. To make a hole, you need to penetrate the workpiece slowly up and down to prevent the work to broken. This machine also required 2 man works to handle this machine. So the one that hold the workpiece should wear gloves and goggles. Before welding, make sure the ventilation is turned on, because when welding, it will produce carbon monoxide, nitrogen oxide that will be harmful for the person that breathes it in. Other than that, make sure use gloves and auto-darkening helmet and also apron. First, clamp the workpiece tightly. Second, please hold the grinder with both hands to prevent the grinder fall off from your hand. At the same time, wear face shield and glove to prevent the spark get into your skin.
So the first step is measure and mark to make sure the dimension is correct with the given instruction. And then the second one is cutting process using the hand saw. And then the third one is drilling process, which make the 3 small hole and 1 middle hole. And then milling process to make 3 slot and gutter for both top and bottom part of the workpiece. And then the fifth process is turning to make cylinder for the middle part and to make the circle for the top and the bottom part of the workpiece. After that is threading process, which make the holes bigger to ensure the screw is fit through the 3 holes. And then the second process is welding, which joining all the parts. And then the last process is grinding to make the piece smoother. So this is our final product of the turbine blade.
Things that need to improve is first in planning and measurement to prevent misalignment. Accurate planning and measurement are critical to ensuring components fit together properly during assembly or fabrication. Misalignment often results from incorrect or rushed measurement, leading to rework, inefficiency, and potential product failure. Utilize proper measuring instruments like calipers and micrometers, and double-check all dimensions before cutting or assembly parts. Second, operate machinery properly to avoid any defects. Incorrect machine handling can cause defects such as burn, warping, or inconsistent cuts. Operators should be trained thoroughly on the correct usage of machines, including setup, maintenance, and safety protocols. Regular calibration and inspection of machinery ensure it performs accurately and reliably. Following proper procedure minimizes downtime, enhances product quality, and extends equipment life. Finally, apply oil to workpieces to prevent rust and maintain finish quality. Metal workpieces are prone to rust when exposed to moisture, especially during storage or extended production periods. Rust can degrade material properties and affect the visual and functional quality of the final product. Applying a light coat of oil or rust preventive compound help create a protective barrier, preserving the workpiece integrity and ensuring a clean, high-quality surface finish. Make this step part of routine handling and storage procedures.
Talking about problems, can you imagine this? Taking a walk in the sunny days, and then
defect.
yes, ladies and gentlemen, defect is one of the most annoying things that could occur during manufacturing. But rest assured, because there are no obstacles that big enough for
The greatest technician that's ever lived.
So, what is the problem that our group are facing? Well, one of the problem is unaligned hole and unaligned slope for a screw and a blade. So, what is the solution for this problem? Our team have been searching, finding, and thinking about it, and then we came up with this idea. We decide to drill the hole and then do the milling on the workpiece so that the hole and the slope will get even bigger and the blade and the screw will fit in back. So that is from my part. Thank you, and we go to the next session.